Welcome, class, to the Intro to Java Programming. In this lesson, we will review abstraction, one of the major building blocks to object-oriented programming, along with how it works with the interface, accessibility, and some code examples. Object-oriented programming is about creating objects that contain both data and methods. The four building blocks for object-oriented programming are encapsulation, inheritance, abstraction, and polymorphism. In this lesson, we'll focus on abstraction with the interface. Abstraction means using simple things to represent complex things. Abstraction is a process where you show only relevant data and hide unnecessary details of an object from the user. And an interface provides a mechanism that allows unrelated classes to implement the same set of methods. This is another form of abstraction meant to have a simple thing represent a complex thing. Yes, this definition is a little vague until you better understand the true meaning. Let's start with an example that covers an overview. An interface and a class can be connected together to form a parent-child-like relationship. However, the interface is a template that the class must follow. Inside the interface can be abstract methods, meaning only the method's signature is declared, no body or code block. The class must implement all the methods defined in the interface. Implement means the class must contain the specific method and the code block must be written. Once the class implements all the abstract methods, it is considered to be a concrete class and can be instantiated. Many different classes can implement the same interface. Each class must implement all the methods defined in the interface, but each class will implement the methods in their own unique way. An interface is a template or a contract that a class must follow. Here's an example of an interface. Many of you own or have seen an automobile. There are wheels on the automobile. Each wheel consists of a tire and a rim. Each wheel rim is mounted to a wheel hub. Each wheel hub can have bolts. Often there are 4 or 5 bolts, but there can be more depending on the vehicle. The wheel hub is an interface. Let's use the wheel hub with 5 bolts. Now imagine we have several wheel rims to choose from. Which one should we use? The wheel rim is the class implementing the wheel hub interface. That means only wheel rims with 5 holes can be mounted to wheel hubs with 5 bolts. Here we can choose from 3 wheel rims. They all have 5 holes. This wheel rim has 4 holes and will not fit. This wheel rim with 4 holes is not implementing the 5-bolt wheel hub interface. Remember, the interface is a contract or a template to be followed. Like the 5-bolt wheel hub, the class that implements the interface must follow that contract. This wheel rim has 5 holes and is following the contract. This wheel rim has 4 holes and is not following the contract. Let's review how to create an interface and its contents. Here is a monster interface. Here is the code for declaring an interface. The access modifier is public, followed by the keyword interface and the name. In this example, we are using the name monster. You cannot instantiate an interface by itself. Inside the code block can be 0 to many abstract methods. The keyword abstract is not needed. There should be a return data type like string, a method name like getMonsterName, and optional parameters for the method. You should also notice there is no access modifier like public. The return type can be void or any valid data type. And there is no curly braces or code block, only the method signature. The Goblin class will be implementing the monster interface. Public class Goblin is how to create the Goblin class. The keyword implements is used to indicate the interface or interfaces used. Monster is the interface. The Goblin class should follow all the rules of encapsulation. The class could have private constructors, properties, and methods, and the class could have public constructors, properties, and methods. Inside the class, all methods can access public and private properties and methods of the class. To become a concrete class, the Goblin class must implement the abstract methods of the interface. The Goblin class must have the exact signature of the getMonsterName method. The access modifier public must be used for implemented methods. The annotation keyword @override should be placed above the method signature. @override is not required, but it is encouraged to assist other developers in the future. Inside the code block will be unique code specific to this Goblin class. Let's imagine there's a game control class that instantiates the Goblin class with the Goblin data type. It is not common to use the Goblin class as the data type, but it is allowed. Using the previous example, let's say the monster interface has one abstract method, getMonsterName. The Goblin class implemented the getMonsterName method. The game control class has access to all the public properties and methods of the Goblin class, including the abstract methods from the interface as they are implemented as public. It is important to note that the game control class can access public methods and properties not defined in the interface. For example, imagine the Goblin class also has a public method called isSleeping, which will return false 90% of the time. For this example, let's just return false. The game control class can access both getMonsterName and isSleeping methods, because the child data type used is the Goblin class. Let's imagine the game control class instantiates the Goblin class with the monster data type. It is common to use the monster interface as the data type. Using the previous example, the monster interface has one abstract method, getMonsterName. The Goblin class implemented the getMonsterName method. The game control has access to all the public properties and methods of the monster interface if implemented by the Goblin class. Again, imagine the Goblin class also has a public method called isSleeping. The game control class cannot access the isSleeping method or any properties and methods from the Goblin class because there is no abstract method in the monster interface for isSleeping. The game control can only access the getMonsterName method because it's an abstract method of the monster interface. It's important to understand why the isSleeping method in the Goblin class is not accessible even if it's public. Remember, the game control created the variable myMonster with the monster interface data type. Here is the monster interface. Only properties and methods of the monster interface are accessible to the myMonster variable. The getMonsterName method is found in the monster interface and is implemented by the Goblin class, therefore the game control has access. The isSleeping method is not found in the monster interface, so even if it is public in the Goblin class, the myMonster variable in the game control class cannot access the method. Although not recommended, the isSleeping method is available with casting. Let's look at the code for the interface. Open the OOP intro project in IntelliJ, close any open class tabs. Navigate to or create a test package called Abstraction. Let's create a new test class called Monster Interface Test. Let's make some space, copy in this first test. This test will prove you cannot instantiate an interface class. Let's create a new class called Goblin Interface Test. For all of these tests, I will refer to the interface class as the parent and the implementing class as the child. This first test will check the public and private properties available to the parent class. A new Goblin interface object is instantiated as the variable name parent. Please note the data type is monster interface class. The value from the parent string interface constant is stored in a variable called actual. The next line asserts the value matches the expected result. The parent object variable is not allowed to access public or private properties of the child class. These two lines will generate an error. This test will check public and private properties available to the child class. A new Goblin interface object is instantiated as the variable named child. Please note the data type is a Goblin interface class. The value from the parent string interface constant is stored in a variable called actual. The next line asserts the value matches the expected result. The value from the child public string is stored in a variable called actual. The next line asserts the value matches the expected result. The child object variable is not allowed to access private properties of the child class. This line will generate an error. This test is very similar to the parent property test, except it will show public and private methods available to the parent class. A new Goblin interface object is instantiated with the variable name parent as a data type monster interface class. We will prove the parent object variable can access public implemented methods of the parent interface. The parent object variable is not allowed to access public methods from the child class unless casting is used. And the parent object variable is not allowed to access child class private methods even with casting. This final test is very similar to the child property test, except it will show public and private methods available to the child class. A new Goblin interface object is instantiated with the variable name child as a data type Goblin interface class. We will prove the parent class public methods are implemented and accessible. We will prove the child class public methods are accessible, and the child class private methods are not accessible. Let's navigate to or create a Java package called Abstraction. Let's create a new class called Monster Interface. Some IDEs will offer an option for an interface. Verify that you have public interface, monster interface. Change this if necessary. There is one property. This property is considered public, static, and final, meaning it cannot be changed. There are two abstract methods. The keyword abstract is not required. Any class that implements this interface will need to implement these two methods and provide code in the code block. Let's create a class inside the abstraction package. Let's call this class Goblin Interface. In the class declaration, use the keyword implements and then implement the monster interface. There are three properties, two private and one public. Properties from the interface cannot be overridden. This constructor is used to set the monster name property. These two methods will implement and override the parent abstract methods. The code block contains the unique code for this class. Notice both methods use the @override annotation. These are two other methods, one public and one private. This method proves all the public and private methods from the Goblin class are available. It also proves the public property from the interface is available. Let's go back to the monster interface test. Notice there's a compiler error. This proves you cannot instantiate an interface. Let's comment out this test. Let's go back to the Goblin interface test. There are several compiler errors. All of them will prove accessibility issues with the interface and the implementing class as noted before. This test will verify the parent object variable's access to properties. These two lines prove the parent object variable cannot access public or private properties from the child. Comment these lines out. This test will verify child object variable's access to properties. This line proves the child object variable cannot access private properties. Comment this line out. This test will verify the parent object variable's access to methods. These two lines prove the parent object variable cannot access public or private methods from the child. Comment out these lines. This test will verify child object variable's access to methods. This line proves the child object variable cannot access private methods. Let's comment this line out. Let's go back to the Goblin interface class. Properties cannot be overridden from the interface. Let's comment this out. Let's run these tests to prove the interface and implementing child class work. This test passes. This test passes. This test passes. And this test passes. Here's a summary of all the test code we wrote for this lesson. You should now have an understanding of abstraction with an interface, which is a contract that all implementing classes must follow. A visual example was provided to help explain the interface with the use of a wheel hub and a wheel rim. The implementing class should follow all the rules of encapsulation. Accessibility examples for properties and methods were covered. In the next lesson, we'll discuss abstraction. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!